Hello, welcome to the introduction video on the fundamental trigonometric identities. So the first thing we are going to do is review what we already know about the trigonometric identities, which ones we already know, and then we're going to introduce a few new ones. Eventually, all of these are going to need to be memorized. You'll work with them extensively, so often most of them come naturally. So let's take a look at the ones we already know, the reciprocal identities, that the sine is 1 over cosecant, and the cosecant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent's 1 over cotangent. Cotangent's 1 over tan. So in other words, remember they're just reciprocals. So like if the sine is equal to 3/4, just pulling something out, then that would mean that the cosecant would be equal to 4/3. That's the same exact thing as they're saying in this piece. Let's go to the next one. From Imp 4, we know that tangent is sine over cosine. So cotangent's the reciprocal, or cosine over sine. Again, these identities up here you've seen before. So we're going to introduce you to some other identities, and I'm actually going to start with the even-odd identities on the bottom of that note page I gave you. The reason I'm starting there is this should be, again, familiar from Imp 4. It's just looking at it differently. It's not in context. It's on a yellow piece of paper. So sine of negative u is equal to negative sine u. So why does that make sense? Remember from the Ferris wheel situation, the sine is the height off of the ground. So if this is an angle u, negative angles go backwards, they go counterclockwise as opposed to clockwise. So this would be negative u. Now sine talks about the height of the Ferris wheel. So the sine of this piece, is the opposite, that's what negatives mean, opposite of this sine value. Is that true? Are these heights opposite? Yes, this is a positive height up here, and this is a negative height down here. Thus, if the sine of negative u equals negative sine u, then doesn't it make sense that its reciprocals will also have the same relationship? The cosine of negative u, the cosecant of negative u equals negative cosecant u. So now we have to look at the cosine of negative u equals the cosine of u. And so let's once again go back to our fireworks experience. I believe you wrote about these in your portfolio. Here is u, here is negative u. You need to remember that cosine talks about the left or right position of the Ferris wheel. This is, if I make the triangle, I'll make the whole entire triangle. This is the cosine value of positive u, and it happens to be the same for negative u. Therefore, they're equal. What logically follows if those two are equal? Well, then the secant of negative u equals the secant of u. So if the sine of negative u equals negative sine u and cosine of negative u equals cosine u, does it make sense that the tan of negative u equals negative tan u? Well, let's see. Tangent is sine over cosine. So the sine, this would be the sine of negative u over the cosine of negative u. You're painfully watching me type this with a mouse pad. And we know that the sine of negative u from up here is equal to negative sine u. And we know that the cosine of negative u equals cosine u. Then what we're going to do is switch colors and go, hey, this is tangent, negative tan u. So if tan of negative u equals negative tan u, cotangent of negative u equals negative cotangent u. So these identities right here are kind of familiar, but might need a little bit more. Now we're going to go to the next one that I seem to think are the most familiar. Just not moving that screen. The Pythagorean identities. Again, from IMP4, we use the Pythagorean identity, sine squared plus cosine squared equals 1. So now we're going to come up with a couple more identities. Scrolling down the page. This one is the one we're familiar with. Why do you think they're all called Pythagorean identities? Don't they look a lot like a squared plus b squared equals c squared? That's why we call them Pythagorean identities. Oops, sorry, I gotta explain them a little more. So, on a side note, I have a hard time memorizing things. Like, I'm going to memorize 1 plus tan squared equals secant squared, 1 plus cotangent squared equals cosecant squared, and it just boggles my mind. I'm not very good at memorizing. I know this one because it came up in IMP4, and it comes up a lot, and I can memorize one thing. Sine squared plus cosine squared equals 1. From there, I can develop any of the other two identities. So, if I take, I'm going to do this. It's all linked. Sorry. Never mind. I'm not going to do that. I'm going to go like this. The sine, if I do sine squared plus cosine squared equals 1. And I'm going to divide everything by sine squared. Equals 1. I'm going to divide everything by sine squared. I'm allowed to do that because I'm doing the same thing to every single item here. And then you might see where this is going. Do you know which identity it's developing? So here, sine squared over sine squared is 1 plus, what's cosine squared over tan squared? Cosine squared over sine squared? Cotangent squared. And then what's 1 over sine squared equal? Cosecant squared. Oh, and look, there's your Pythag identity. Now what I'm going to do is I am going to duplicate this page and edit. So let me duplicate it, who cares? Okay, so now I'm going to develop the other identity. So instead of dividing by sine squared, I will now divide by cosine squared. So why don't you take a moment and try that on your own. And now I'm going to divide by cosine squared. If I do that, sine squared over cosine squared is tan squared. Cosine squared over cosine squared is 1. Oh, it's this one, rearranged. Equals 1 over cosine squared is secant squared. So what you'll often see on like my answer keys when I'm doing out work is I rewrite this, and then I do this division, and I develop the other identities because I have never committed these to memory. I develop them all the time. So, then we have the final identities that you have not seen, which are the cofunction identities. You notice that they are similar. Sine is sine of pi halves minus u equals the cosine of u. Cosecant of pi over minus u equals secant u. Notice how those are very similar because cosine goes with secant, sine goes with cosecant. The cosine of pi halves minus u equals sine. And notice how that's very similar to this one here, filling in the blanks. And then the tangent of pi halves minus u equals cotangent, and the reciprocal is also true. So you're like, so who cares? Well, on the AP Calc first homework assignment, they had this problem, and pi halves over x over 2 minus u, it was minus x, and it was over x. And they said, it's a limit as x approaches 0, but I can't have 0 in the denominator, so they had to simplify. So I said, oh, that's a special identity. This right here, and I whipped out my trig book. That is the same as cosine u. So then we end up with 1 minus cosine u, cosine x, sorry, because it's an x now, over x, which happened to be a special case from their text notes, and they're able to find the limit now. So, see what I just did there? That's called simplifying. That's where we're going to head to next. That is the end of this lesson on the introduction.